Okay, here we have number 1. This is saying if two triangles are congruent, then they are similar. Well, I've drawn two triangles here, and remember, to me, congruent means all the sides and angles are the same. So if we marked these here. In particular, though, if two triangles are congruent, all the angles are equal, and that also can be used to prove similarity by the AA theorem for similarity. If a triangle has two angles that are congruent, then they are definitely similar. So the answer to this one is true. Here I've drawn two triangles that are similar. You can see all the angles are the same, but I've drawn them in such a way that they are definitely not congruent. This is approximately a scale factor of 2 is what I tried to draw here. So you can see that it's easy to find a counterexample to this one. So the answer to this one is false. Here I've drawn two equilateral triangles. Remember, an equilateral triangle has all sides that are congruent, and as a result all the angles are also congruent. They're all equal to 60 degrees. Because they all have the same angles by AA, they're going to be similar. You could also use the SSS theorem from similarity. If three triangles have sides that are proportionate, so in this case, because they're all in the same ratio, this one would also work, but I think the easier one is to see angle here. So this one is true. So this one is, the idea is just to use this idea of ratio to figure out what the scale factor is. Really the most difficult part of this problem is the fact that the Sears Tower here is measured in feet and the model of the tower is measured in inches, so we need to get those into the same units. I find this one a little easier to work with, so I'm going to just convert that to 2 feet. Because there's 12 inches in a foot, so 24 divided by 12 equals 2 is how I got that. And now I have them both in feet, and it says what's the ratio of the height of the model to the Sears Tower. So we want the model first, so we have 2 to 1450. But we can think of that almost as a fraction here, and it can be reduced further because there's a common factor of 2, so 1 over 725. So this ratio simplifies to 1 to 725, which is really the same, even though it's written like this as a ratio with the colon here. The idea is that it's working like a ratio, like a fraction, so you can reduce out common factors. So the answer is 1 to 725, or A. Whenever you're working with proportions, one of the most common operations we're going to do here is to solve something is we want to cross multiply and set equal. And so if we do that, we have 5 times B on this side, and we have 3 equals 3 times A, just by cross multiplying, setting equal. Now this particular problem is asking what 3A is equal, which we can see already is here. So we know the answer is relatively simply 5B. C. These are going to be number 6 and 7, just more cross multiplying, solving. This one, we could actually even reason through it. I may do that instead of just doing the cross multiply. What I like to do on something like this one to see what's happening is, I'll rewrite it here, and I look at since I have 2 numbers in the denominator, I ask myself, what do I need, what happens to go from 7 to 35, and I know that I'm multiplying by 5 to do that. And so then I can just do the same thing on the top. In order to convert the 5, I just multiply it by 5, and I'll get 25. And so I know M would be 25. It's just reasoning through, because I can tell from the denominator that scale factor or the multiplication factor is 5. If you wanted to do the cross multiply approach, also fine. Here we would have 7M equals 5 times 35, which I'll leave like that because it'll be easier to simplify, because if I divide both sides by 7, I get 5 times 35 all over 7. 35 cancels to 5 with that 7, because 35 over 7 is 5 over 1. M equals 25. Number 7 here is a little more algebraic. I can't use that approach I just used for number 6. Here we need to go straight to the cross multiply approach. So that one is 8x, 8 times x. This one is 5 times x plus 6. Make sure you write these parentheses here if you're still a common problem I will see sometimes on this is to write this as 8x equals 5x plus 6 and forgetting and then making a mistake there. It's really important to keep that x plus 6 as a standalone factor with the parentheses because now we're going to distribute the 5. So this is wrong. I'll cross that. Oh, actually it's right when I fixed it, but I'm going to cross it out anyway. Here we're going to multiply that 5 to each factor. So we have 8x equals 5x plus 30. I'm going to subtract 5x from both sides to get the x's together. 3x equals, these are going to be 0x, 30. X is 10 by dividing each side by 3. Here we have a couple more. Again, this one needs to be done with cross multiply. So the first diagonal there is 4 times 18, and that's going to equal 2x times x. 2x times x times x is 2x squared. It's not 3x. Don't make that mistake because it's not 2x plus x would be 3x, but 2x times x is 2x squared. And then 4 times 18 I'm going to leave alone. I'm going to get the x by itself, or x squared by itself, by dividing each side by 2. 4 divided by 2 is, that's a 1, that's a 2, so 2 times 18 is 36. Those cancel. X squared. Now this is a root here, so x equals plus or minus the square root of 36. You have to make sure to take the plus or minus because there's two possible answers when you square something. And then this will be plus or minus 6 because the square root of 36 is 6. That's the answer. Okay, number 9, same process, just a little bit more algebra involved here. So this first one is 3n times, again, making sure to keep it in parentheses, n minus 5. This one is n minus 6 in parentheses times 3n plus 1 in parentheses. Now we have to do our algebra here. This one is a single factor times a binomial, so we're going to distribute 3n squared minus 15n. And then here we have to do FOIL. So n times 3n is 3n squared. Do the outer here now. N goes with 1, so that's plus n. The inner minus 18n. And the outer, n times 1, is plus n. Now we just have a bunch of terms to collect here. We can see that we have 3n squared on both sides. So if I subtract 3n squared and 3n squared, those do the same thing to both sides, or those will go away. I'm just going to do that first, actually, right here. I have just noticed an error here in what I did, so I'm going to erase this one right here. When I did this foiling, I didn't do the right last term here. What I really should have done was negative 6 with 1. So this term right here on the end should be minus 6, not what I had there previously, because negative 6 times 1 is 6. Okay, so now I can still simplify here. Minus 15n, those cancel. N minus 18n is negative 17n minus 6. And then I add 17n to both sides to get the n's together. That gives me 2n. These cancel, equals negative 6. And divide both sides by 2 to get n equals negative 3, which is answer A. So this one is a straightforward set up the proportion. So we know that on the map, 1 centimeter is proportionate to 120 kilometers. And then in reality, we know that Melbourne to Canberra is 463 kilometers. So we need to figure out what that is in centimeters. One thing you can do is just eyeball this right here. We can see that from 120 to this number here is approximately 4, because like 120 times 4 is 480. And so that's pretty close to 463. And you can, if we look at all these answer choices, this one is quite close to 4. So that would be one way to just reason through it. Otherwise, we can just do the cross multiply. So if I put this as x here, 120x is going to equal 463. X will be 463 over 120. And if you put that into your calculator, you'll get 3.9 to the nearest tenth. So in both cases, the answer is B.